Hello students, welcome to my online class. Myself Firoz Sheikh, and today we are going to start a new chapter, chapter 6, squares and square roots. So generally when we used to hear squares, generally it comes in our mind a figure. A figure comes in our mind which like this, where it's a closed figure made up of line segment and all sides are equal. So this is all about geometry, but when we talk about squares and square roots, we are talking about in algebra. So what is square exactly? Suppose a square is a number which is the product, or you can say square number is a product of the number with the number itself. Example, suppose 2, this is called a square, or you can say 2 square equal to 2 into 2. If I write 4 square, it means it is the product of the number with the number itself. 5 square, it will be 5 into 5. 6 square means 6 into 6. This is all about square. So the result of this one will be 2 to the 4, 4 4 the 16, 5 4 the 25, 6 is the 36. This is all about perfect square. These numbers are what? A squared number or a perfect square. So a square number is the product of a number with the number itself. See 16, it is the product of a number, that is 4, with the number itself, means 4 into 4. Same thing, 25, it is the product of a number, that is which is 5, with the number itself, 5 into 5. So this is all about squares. So now come to the next topic. Our next topic is properties of perfect square. What is perfect square? Perfect square is a product. A product when a number is multiplied with the number itself. Simply, as I explained earlier one, as I told you, 4 into 4 equal to gives you 16. This is the product. This number, or you can say squared number, is the result of multiplying a number with the number itself. That is what? A perfect square number. Let's take an example. Listen here. 1 square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square and 10 square. Let's see what will be the result. 1 square will be 1, 2 square will be 4, 3 square is your 9, 4 square is our 16, 5 square is our 25, 6 is our 36, 7 square is our 49, 8 square is 64, 9 9 is 81 and 10 10 is 100. Now you have to clearly look out all the square of the numbers. These are the basic numbers where you will get in the ones place or ones digits. Is that clear? Means ones place you will get 1, either 2 or 3 or 4 or 5, 6, 7, 8, 9 or 0, and of any size of numbers. So whenever you square a number 1, you will always get 1 at the ones place. Whenever you square number 2, you will always get 4 at the ones place. For example, here also 3 3s and 9. Means suppose if I take 13 as a number, this is suppose number, okay, and this one is our square number, okay, or you can say square number or perfect square. Let's say perfect square or squared number, okay, this one. Now if we take 3 and we square it, whatever number will come, you will find that 9 will be at the unit place. Suppose we take 13. 13 in ones place. 13 into 13. Let's take 13 into 13. 3 3 is 9. 3 1 is 3. 1 3 is 3. 1 1 is 1. 9 6 1. See, we squared a number 13. We get a result 169, where our ones digit of the number 3 gives the result a product, what is squared number, and that is having 9 at the ones place. Are you getting me what I want to say? So whenever a number is having 3 at the ones place or 7 at the one place, you will always get a squared number having 9. See, 9 at the ones place. Once again I want to say that. Let's take example of 2. So let's take 12. A number 12 into 12. 2 2 ja 4, 2 1 ja 2, again 1 2 ja 2, 1 1 ja 1. Here you will get 1 4 4. Sorry, 4 4 1 means 1 4 4. So whenever you multiply a number which is having 2 in its ones place, you will get a result, or you can say product, or a squared number, perfect square number, where whose ones place will be 4. So likewise, if you squared a number having 2 or 8 in its ones place, always you will get 4 in its units place or ones place. Is that clear? Once again, let's take an example of this one, 4 and 6. Whenever you square 4 or any number having 4 in its ones place, you will get 6, the product, or you can say the squared number you will get, that will have 6 in its unit place or ones place. Same thing is about 6 also. Whenever you square a number having 6 in ones place, you will get a result which is having 6 in its ones place. Same thing for 1 and 9, you will have 1 1 at ones place. For 2 and 8, you will have 4 4 in ones place. For 3 and 7, you will have 9 9 in ones place. For 4 and 5, you will have 6 6 in ones place. And for 5, you will have 5 in ones place. And whenever we square a number which is having 0, that 0 will double up. Suppose if I square 10, it will gives you 100. If I square 100, it will gives you 10,000. Simply double the number, means whatever may be the number of zeros in a number, on a perfect square you will get even number of zeros. Remember that. So now we can give a conclusion. If a number ends with 1, okay, ends with 4, 1 1, okay, 4 4, ends with let's take 5, ends with 6 6, and sorry, not and 9, see 9, okay, and 0. See, you have seen 1 2 3 4 5 6 7 8 9 and 0, all the numbers I have used here. Okay, right now these are in single digit. If you take double digit also, if you may make a triple digit also, whenever you make the square of these numbers, you will always get these numbers 1 4 5 6 9 0 at the ones place of a squared number. But it doesn't mean that if a number is having 4 is a perfect square. Remember that. Let's take an example of this one, 36. Let's take an example. So 6 into 6 gives you 36. Okay. But if I write, since it has 6, as you told earlier, that's because whenever you multiply a number which is having 4 in its units place, you will always get 6. So 6 here, or you will multiply 6, you will get 6 here, so 6. But if I write 26, will it be a perfect square? No, because see, 5 into 5 gives you 25. It is not equal to 26. So the number which is having 1 4 5 6 9 or 0 in its unit place, it may be a perfect square number, but it doesn't mean it all the time it will be a perfect square. See, 36 is a perfect square number, but 26 is not a perfect square number. So it is the possibility is there whenever number is having 1 4 5 6 9 and 0 is there in the ones place of a perfect square number, then that will be the possibility is there that that number will be a perfect square number. But one condition is that, see, which are the number are missing here. Look at here, 1 and 4 means 2 and 3 is missing in between this one, 1 and 4. Then 4 5 6, then 7 and 8. See, 7 and 8. Are you getting me what I want to say? We can't give guarantee that the number is having 1 4 5 6 9 0 at unit place, that will be a perfect square number. But we can give guarantee that if the number is having 2 3, 7, 8 in the unit place is not a perfect square number. Is that clear? Because we have used all the numbers and we have squared the numbers, we got the result. Those are perfect square, where you can see that 1, 4, 9, 6, 5 and 0 are coming, but 2, 3, 7, 8, these 4 digits are missing. Means it shows that a number is having 2 in its ones place, or 3 in its ones place, or 7 or 8. Such numbers are not a perfect square number. And one more thing about 0, if the ending of the number is having odd number of zeros, right now see, if I square 10, I am always getting, see, even number of zeros. If I making a square of 100, I am getting even number of zeros, 1, 2, 3, 4. It shows that whenever you are getting an even number of zeros, the possibility is that will be a perfect square. Possibility is that, okay, because I can say that 100 is the square of 10 square, but 200, how can I say that 200 will be a perfect square? Because we can't get, see, if we make it suppose 12, suppose 11, make it as 11. Now 12 gives you 144. So take suppose 13 is 169. Take it as a 15. 525. 5. 2, 5, 5, 6, 7, then 5, then 1. 5, 2 carry 1. 225. So if you make a square of 15, you are getting 225, not 200. So there is a chances that whenever you are having an even number of zeros, it may be a squared number. But if you are getting an odd number of zeros, that is definitely it is not a perfect square. The number ends with 2, 3, 7, 8, and odd number of zeros are definitely not a perfect square number. So I hope you understood this part. Now come to the next topic. Our next topic is find square of a number, or you can say finding square of a number, or how we can find a perfect square number. See, let me show you one thing here. 1 square, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once again let me write 1 1 is 1, 2 2 is 4, 3 3 is 9, 4 4 is 16, 5 is 25, 6 6 is 36, 7 7 is 49, 8 8 is 64, 9 9 is 81, 10 10 is 100. See, for a single digit number, it is very easy to find a square number. Suppose we talk about 2 digit or 3 digit number, how we will find out? Suppose let's take an example, 72. We need to find the square of this. So we can find like this, to make it little bit simpler form. 70 plus 2 we can write. Okay, 70 plus 2. Then we will use our identity. We know this identity, a plus b whole square gives you how much? A square plus b square plus twice ab. Is that clear? So here in this case we will apply that identity. 70 square, first we will write 70 square means a square, c, plus b square means 2 square, plus twice ab. So twice, then a is our 70, b is our 2. So 7 7 is 49, 4 9, 00 will be there, then 2 2 is 4, then here 2 2 is 4, 728, sorry it is plus 280. So now you can add, very simple, 4 9 0 0 2 8 0 and 4, simply 4 8 this 11 5. So 5 1 8 4. In this way you can find out. Sometime whenever you are getting some bigger digits, 3 digits or 4 digits, in that case you can use suppose 123. So you can say that 123. So you can use it like this, 100 plus 23 whole square. Again you are having some complexities in here. So make it like this, 120 plus 3 also. So for your better convenience, you can arrange the number such that squaring of a number doesn't make you create any problem. So you can arrange the numbers according to your convenience. So in this way we can find the square of a number, or you can find the perfect square number for a smaller digits. And higher digits definitely you have to multiply for a long time, but that's why I used to say that always try to learn the table up to 20 or 25, like it will be easier for you to calculation. Anyway, so this part is over. Now come to the next topic. The next topic is Pythagorean triplet. What do you understand by Pythagoras? Pythagorean triplet. See, Pythagoras, you have heard Pythagoras theorem that in a right angle triangle, okay, if this side is base, if it is perpendicular and this is hypotenuse, this is the 90 degree, the opposite side of the 90 degree is known as hypotenuse. This is a right angle triangle. So according to Pythagoras, the hypotenuse square is always equal to the sum of the square of perpendicular plus square of base. Hypotenuse is the side which is opposite to 90 degree. According to Pythagoras theorem, the square of hypotenuse will always equal to sum of the square of perpendicular and the square of base. Very simple. So if we take an alphabet like H, P, B, if they are Pythagorean triplet, then the relation will be H square equal to P square plus B square. So let's take an example. Let's take, suppose 3 square plus 4 square equal to how much? Let's see. 3 square gives you 9, 4 square gives you 16, 9 plus 16 gives you 25, and we know that 25 is a perfect square number, and the number will be 5 square. So here we can say that 3, 4 and 5 is a Pythagorean triplet. Okay, so right now I have written like this: 3 square plus 4 square plus 5 equal to 5 square, because after squaring you will get the same result here. But if there are some bigger numbers, so how you can say that whether these three numbers, if any three numbers is given here, so how you can find out whether it is a Pythagorean triplet or not? See, for a Pythagorean triplet, so see, twice m, these are the first member, second member, third member. You can say Pythagorean triplet, 3 members are there. Each one is the first member or any member, the second member, third member, like this. Okay, so one of the member of a Pythagorean triplet will be twice m, another is m square plus 1, and another one is m square minus 1. Okay, now suppose if somebody gives you a number 16, one of the member of a Pythagorean triplet is 16, and they are asking find the other 2 members. How you can find out? So let's take an example. Let's take twice m equal to 16. You may take m square plus 1 equal to 16 or m square minus 1 equal to 16. But in this case, what you will get? M square equal to 16 minus 1, m square equal to how much? 15. So ultimately m equal to under root of 15, and 15 is not a perfect square number. So it is not possible to find m equal to a whole number. Here in this case also, m square equal to 16 plus 1 gives you 17. M square, C, 17 is also not a perfect square number. So what you will do? So you will take twice m equal to 16. So in this case, what happened? M equal to what? 16 by 2 means m equal to 8. So here m, you are getting a whole number 8. After finding the value of m, you can find the rest of the members. Here it will be 8 square plus 1. Here 8 square minus 1. 64 plus 1, it will be 64 minus 1. So it will be 65 and it will be 63. So first member was 16, another was 65, and the last was 63. So in this way you can find out. So clearly by looking at the value, we can say that this m square plus 1 is the longer side of the triangle, and this 16 and 63 means twice m and m square minus 1 is maybe a perpendicular base, whatever, when we compare it with the triangle and all. But the Pythagorean triplet is like that. The first member will be twice m, the second member will be m square minus 1, and third member will be m square plus 1. Okay, these are the three members and we know as Pythagorean triplets. So I hope you have understood this one. Now come to the next topic. Next topic is square root. Now already we have discussed square. What is square? Now we will talk about square root. So what is square root? See here, if I write like this, 5 square, it will give you 25. So 25 is the square of 5, then square root of 25 will be 5. Means the symbol is like this, 25. If I write like this, so it will be, see, 25 means what? 5 square means 5 into 5. So square root of 5 into 5 means here we can say that 5 square, so it will be 5. Okay, how it happens? Means it will be equal to 25 to the power half. This is the symbol of square root. If we want to show this thing in the exponent notation, then it will be half. So ultimately what will happen? See here, 5 into 5 to the power half. Again it will be 5 square to the power half. We have already learned in exponent, then it will be multiplied. So 5, 2 into half, 2 cancel, ultimately 5 to the power 1 equal to 5. So in this way we find the value. Means if we square a number, if we multiply 2 times, 5 into 5, let me write once more here, 5 into 5 like this. Now it will be more easy to understand. Now 5 into 5 gives you 5 square, which is equal to 25. Means 25 is the square of 5 into 5. Okay, when we multiply a number with this number itself gives you a perfect square number. So what will be the square root? Means if we give this symbol, it shows that 25 is 5 into 5. 5 into 5 gives you 5 square. This square and root will cancel out like this, and this 5. So square root of 25 will be the number which is multiplied by itself gives you the perfect square number. Are you getting me what I want to say? That very simple. When a number is multiplied by the number itself gives you a product that will be a perfect square number. The square root of that perfect square number will be the number itself. So that is, in this way we can find out the square root. Now there are three possible ways how to find the perfect square number. Let's take an example. First method is what? Repeated subtraction. Second method is very simple, by prime factorization method. Okay, and third one is division method. Okay, division method you can write in all the method. So we will try repeated subtraction. Let's take an example. Any squared number, it will be easy. Let's take 12 into 12 gives you 2 to the 4, 2 1 is 2, then again 2 1 is 2, 1. So 144. It's a perfect square number. Let's take an example of this one. So 144. The first method said that repeated subtraction, but subtraction, we will subtract the square number by which number? We will subtract the numbers by all the, you can say, positive odd numbers. See how we will do this one. Step 1. In step 1, 144 minus first odd number will be 1, gives you 143. Okay. Now step 2. This 143 will be subtracted by the second odd number. It will be our 3, 140. On step 3, we are getting 140 subtracted by next odd number will be 5. So it will be 135. On step 4, 135 is subtracted by the next odd number will be 7. How much you will get? 15, 3, 8, 128. Okay. Now on step 5, 128 minus next odd number will be our 9. We'll subtract, means 9, 1, 1. On step 6, we are getting 119 minus next odd number will be our 11. So here 8, then 0, 1. On step 7, we will subtract 108 by the next odd number will be our 13. So 5, 6, 7, 8. Here will be 5, here 10 minus 1, 95. Okay. On step 8, 95 is subtracted by how much? Next will be 15. So it will be 0 and 8, 80. On 9th step, it will be 80 minus next prime number will be our 17. So 10 minus 7 gives you 3 and 7 minus 1 gives you 6. On step 10, we are getting 63 minus 19 gives you how much? 19. 4 gives you 5 minus 1, 4. So on step 11 gives you 44 minus then 21. So here will be 3 and 2. And on last step 12, see 23 minus next odd number will be 0. So in this way, see repeated subtraction of the odd numbers, positive odd numbers, consecutively we will subtract. 144, our square number is 144. We subtracted 1, we got 143. The next is 3, odd number. So 144 subtracted by 3, 140. In this way, consecutively, whatever the result will come, we will subtract by the next consecutive odd numbers. In this way, we will get 0. If it is a perfect squared number, definitely we will get a 0. And which step we will get 0? We will get 12. So we can say that square root of 144 gives you 12. Because we know that just now I find out 12 and 12 is 144. Then I took that example so that I can show you the this thing by repeated subtraction. So this will be the answer. Okay. So I hope it is very much clear to you. Now come to the next method. It is what? Prime factorization. So let me show this thing. Okay, prime factorization method. So here, same example, let's take same example 144. Now 144, prime factorization very simple. This even number. So first we will start with the smallest prime number by 2. 2 7 is 14, 2 2 is 4. Okay, 2 3 is 6, then 12, 2 6 is 12. Then again 2 1 is 2, 2 8 is 16. Then again 2 9 is 18, then 3 3 is 9, then 3 1 is 3. So we can see here very much clearly that 2 into 2, 2 into 2 into 3 into 3. Okay. Now square root of 144 will be square root of entire thing, 2 into 2 into 2 into 2 into 3 into 3. Okay. Either I can directly say that take the pairs and come out of the square root. 2 into 2 into 3. For these two pair I will write 1 2. For these two pair I will write 1 2, and for these two this one 1 3. Okay. Now we can say that 2 2 is 4, 4 is 12. So again we are getting 12. It's very simple. Or if you some are having doubts on how it will come like this, so it's very simple. See, 2 square into 2 square into 3 square. Okay, am I right? Again, see, by exponent, we have already did the exponent chapter. In exponent, we know that if the base are different but the powers are same, so it will come under the same power. So 2 into 3 and a square like this. So 2 into 3 square is there, then power will be half. So 2 into 3, this will multiply. 2 into half, 2 to cancel, ultimately 2 into 3, ultimately 12. In this way it will come. It's very simple. Okay. So by repeated subtraction, you have learned what we will do. First we will subtract, starting from the smallest odd number, and then consecutively we will subtract the result with the consecutive odd numbers. And in this prime factorization, simply we will try to find all the prime factors of the number, and we will see how many pairs we can make, and that thing will come out under the root, and we will get the result. Now come to the last, division method. In division method, we will take the same example, 144. Let's take 144. So for division, we know that we used to draw like this, no? Sorry. 144 like this, okay? But for division method, we are finding the square root. So remember that whatever may be the number, suppose 2, 3, 8, 9, 5, for example. So this type of number where there is no decimal here, so we will start pairing from the right hand direction to the left hand direction. In this way, these two number we will pair, these two number will pair, and one number is there, so one bar will be there. Is that clear? If it is a squared number, suppose we don't know, I have taken randomly this number 2, 3, 8, 9. If it is a squared number, the squared number will be, or you can say the square root of this number will have 3 digits. 1, 2, 3. Number of bars shows that whenever you find the square root of this number, you will get the result in 3 digits. Very simple to find out. This fact I will explain in while doing the exercise and all. Okay, now we will start pairing from right hand side to the left hand side. 2 number 1 bar, 2 number 1 bar, single number 1 bar. Okay, but if a number is having, suppose same thing, if I write 2, 3, 8, 9, 5, 4, 9 for example, and decimal is here. So number which is on the left hand side of the decimal, same thing, we will start pairing from right hand side direction towards the left hand direction. But the number which are having, or we can say the number which are on the right hand side of the decimal, we will start pairing from left hand direction to the right hand direction. Means we will start pairing from in this direction, the numbers which are after decimal, and the number which are before decimal, we will start pairing in this direction. Is that clear now? So we will do some problems in exercise, and that will be clear it out. Now come to this part. So here 144 means what? It is on the right hand side. It is on the left hand side of the decimal. So we will start pairing from right hand side. Pair. Okay. Now for this number, what we will do here? We have to use such a number so that if we multiply with the same number, either we will get that number or smaller than that number. Right now it is 1, so we will use 1, 1 ja 1, finish. Okay, now we will square this number, or you can say we will multiply this number, the unit place, ones place with 2. So it will become 2, we will leave 1 place here. Now this pair will come down, 44 will come down. Okay, now we have to use such a number so that by the same number we will write here and we will multiply it. For example, if I write 2, 1, so we will multiply it by 1. So I will write 1 here and this one I will write here. So 1 1 ja 1, 2 1 ja 21, but it is 44. Now let's take 2, if I write 2 here, I have to multiply it by 2. So 2 2 is 4, 2 2 is 4. See, we are getting 4. So if I write here 2, so I will write here 2 also. So I am getting 44, 0. This quotient, whatever we are getting, is our square root of 144. So we can write square root of 144 is equal to 12. It's very simple. So we have finished our all the 3 methods. First we did the repetition subtraction method, then prime factorization method, and division method lastly. So I hope you have understood all the 3 methods very nicely. Thank you.